Alex, I also just told everyone we're almost Kumetri.
Yeah.
Almost Kumetri.
Yeah.
Okay, so Kumetro, do this.
Thank you.
Rock it.
Hey, everybody. So I want to start with the fact that on July 18, 2025, the Genius Act was signed into law in the US. It regulates how dollar-pegged stablecoins are handled in the country. And on the White House website, you can find the following statement. Delivering on promise to make America the crypto capital of the world. And there is a quote from President Trump at the end. The House will hopefully move lightning fast, all caps, and pass a clean Genius Act. Get it to my desk ASAP, no delays, no add-ons. There could be different reasons why would the US government will become pro-crypto. One of them could be that the crypto market cap reached $4 trillion this year. If you compare it with the top 10 stock exchanges in the world, it will be in the top 10. And if it continues its growth, it will reach top 3 in 2029, according to ChatGPT estimates. But there could be another reason why the US government became so pro-crypto. At the beginning of 2025, the Trump coin launched. It already reached $1.5 billion. So that's basically people bought already on this amount. And a nice bonus on top of that is the team made already $100 million in transaction fees. So yeah, you could think any reason you want, but at the end of the day, the token was launched. It was launched on Solana. It's one of the widely used blockchains today. And Solana has a pretty good market cap and volume overall because it's a fast blockchain, and the transaction cost is also good. It's around 1 cent to 10 cents on average. So, and the biggest wallet on the Solana blockchain is Phantom. You can think of a wallet as a banking app with Apple Pay inside it. If you want to buy something, you can go to, let's say, Amazon, choose a product, go to checkout, choose Phantom Pay. There's no such thing, but maybe it will become. And you can see your transaction, like in the first screen. If it's fine, you confirm it, you buy the product. You could do also different other things inside the app. You can send money to your friends, your family, abroad. You can swap from one token to another, from, let's say, dollars to euros, and so on. My last 3 years, I worked in a team that did transaction security for Phantom. I started at Blowfish, where we did transaction security as a service. We worked with multiple wallets. The first one and the biggest one was Phantom. And I'm going to share my experience, my insights, what I got from the experience working there. And also, I will be doing it in the following format. I will state a problem we faced and a solution we found. OK. In 2022, Solana blockchain has lost approximately $500 million to exploits. And from this money, over $100 million have been stolen from users directly. So projects started taking security more seriously, and they started investing in security. That's why 3 engineers from 0x founded this company, Blowfish, to do exactly that, to do transaction security. Let's compare it to the traditional finance. In traditional finance, you have a bank that is a trusted intermediary. If something goes wrong, they can reverse transfers, they can freeze funds, and help you get your money back. But on the blockchain, there is no undo button. If you sign a transaction, you send it, it's final, you lost your money. The good thing, you own your money. The bad thing, you could lose it in 1 second. So that's what was the mindset at Blowfish and Phantom. We used to build this transaction security system. OK, what we did at the beginning, we did transaction simulation. It's a pretty straightforward thing. You want to interact with a blockchain. You go on a website. You get prompted a transaction. You see what the transaction will do to your bank account or like your blockchain account. We can think about it as bank accounts. If something seems fishy, we show you a warning. If we are sure that it's a scam transaction, we show you a big red block screen. We will be speaking mostly in financial operation terms about Solana. I will not go into much details, but I want to emphasize the fact how account balances change in reaction to transaction. You can think as one account is same as a bank account. You have a dollar account, you have a euro account, you have a lei account. So high level, how a simulation works. You spin up a server, you run the Solana client software on it. If a user is trying to make a transaction, you take the transaction, you send it to your own copy of Solana blockchain that is running on your server. You get a response, and the cool thing about Solana, before creating the transaction, you need to specify all the possible accounts that are going to change inside this transaction. You can mark them as writable accounts. And you can figure out what accounts change after the transaction. So you run the transaction on your own copy of a blockchain. You see how user assets change, and you show them a simulation. That happens before actually the transaction is going on the blockchain. So here there is an example. That's a simple transfer of $50. If you look at the last row, the account with the address HGW is sending $50 to the account with an address 6YR. It's pretty simple. Let's look at another simulation. So there is another transaction that shows that you are about to spend $100. So the first problem and the first question is this transaction malicious? Yeah, it depends. It depends of who is initiating the transaction and what it does. In this case, if you look under the confirm transaction title, you see Camino.com. Camino is the largest protocol on Solana for lending and borrowing money. So basically, you can lend your $100 to somebody else. You get it back after a few months. And on top of that, you get some interest. So this exact transaction is a legit one. But you don't have a good way of assuring that a transaction is malicious or not if you don't know the origin of a transaction. So an obvious solution is to introduce a few lists, a whitelist, and a block list. So some domains that we are 100% sure are legit are going on the whitelist. We don't show any warnings for them. If we see a domain that scammed in the past, they go on the block list. And we show a red screen, as in the third screen. And there is a third category of domains that are not on the whitelist and not on the block list. So we kind of don't trust them. And we are being very careful about them. If the transaction seems fishy, we show a warning just to be sure. But there is another problem. Because creating domains and generating them automatically, it's pretty easy. There was an attack. A scammer gathered a bunch of domains, almost for free, and used all of them in single attack to extract some money. But you could say, OK, the domain is just front-end. The actual thing, real thing that's happening is on the blockchain, inside the smart contract. On Solana, we call them just programs. So why wouldn't we just block these programs? So we are introducing a program block list. If a new transaction is interacting with one of these programs, it gets a warning. OK, that's fine. But there is another problem that it's pretty easy to create these programs and to deploy them. We introduced a bit of cost. So deploying 100 programs now costs like $1,000 to $2,000. But scammers see these as a business. If they spend 10K, they steal 100K, it's a net profit. Yeah. So we are not left with some obvious solutions. We need to evolve the system. We need a fast, high accuracy, automatic domain detection. Before going into it, I want to emphasize the first insight is that reacting to scammers is a cat and mouse game. But there are still benefits to it, because we are making scams more complex. This way, we are filtering out the dummies, and more expensive. Some scams become just not profitable, and that's good. There is also a story in the industry that some good amount of scammers are minors. So if they get caught, they get a lighter punishment. That's why when they grow up, they retire, buy a Lambo, buy a house, and live like a good citizen. So yeah, let's go to the domain scanning. The central problem here is how do we know a domain is malicious? It's a pretty hard problem to solve, but OK, let's use our first solution is if a domain is on the block list, we block the transaction. Another more exciting one is using some kind of ML model before LLMs and before all of that. We can use like a basic ML model. We have some patterns. Let's say like the whole reason for a scam to appear is like to trick users into signing a malicious transaction. And if a scam looks similar to a popular website, the user will likely sign the transaction. So scammers usually have some techniques. They can change the top-level domain. On the left, you have the legit domain. On the right, the scam. So you have OpenSea.com versus OpenSea.co. Blur, they can add letters, they can change letters, but they're trying to trick users. So we can detect all of these in the ML model. There are other patterns that allow scammers to generate domains pretty fast and cheap, like using Vercel, using Google, GitHub, other hosting providers. Another solution on top of a ML model for scanning URLs is scanning the content of a domain. So we have a scraper bot that goes to the domain, extracts all the content, and runs through our ML checks. And usually, we can find some assets, some keywords that will allow us to mark them as copycats and mark them as malicious ones. There are some other signals. So scammers are trying to block our scraper. They're introducing this smart while-true debugger trick. But ironically enough, it's also a high signal that it's a scam, because why would somebody try to block a scraper? Another solution that I really like is the behavioral solution. So we give users some behavioral cues that they need to increase alertness. We have a warning. If we see a domain for the first time, it doesn't matter what kind of domain it is, unless it's whitelisted, of course. We show this kind of like suggestion. It's a new domain. Be careful. And if it's a new domain and it's a legit app, that's fine. Just be careful. But if it's a popular domain that is in production for a year, you kind of like start checking, OK, what URL it is, what it's trying to prompt me. And a more complex, kind of like enterprise solution is using third-party providers. Each one is specialized in own area, NFTs, tokens, domains, so on. There is a problem here that mistakes propagate really quick. So if somebody blocks a legit domain, everybody else blocks it, and it's a problem. So what we can do, it's kind of like a skill issue. You just need to track the warnings. You track the skip reasons. You need to have enough data to kind of like build the chain of events from the moment it was warned upon, for the moment it was marked, let's say, as whitelisted because it was false positive. Why we do that? Because we can now track and analyze the blocklist performance. So we build this kind of metrics for every provider, every warning. We track the false positive rate, how many times this warning was enabled on some legit domains. We want to minimize this. We also can see the true positive. If a warning was on a scam domain, it's good. We want to maximize. And the alpha, it just means that this warning was the first one to be on a scam site. So this is like the most important one for specific security providers and warnings. And that allows us to understand what happens within your system, and through time allows you to make better decisions. You see some security provider is becoming like has a poor performance. You can disable, reach out to them. Like you can bump severity on specific warnings if it does good. So it's very useful. Everything was good. We had a good system. We fine-tuned it here and there. But we started to receive some bug reports. The user saw this simulation, free money, everybody wants it. But actually, it just drained the whole account and sent all this money to the scammer. We started to think, OK, maybe we have a bug in the simulation. We checked everything. The code was solid. No bug, but still, something happens. So with time, we figured out that it was a new attack vector. It was a bit flip attack. So in a few words, how a bit flip attacks, there's a pseudocode for generating this kind of bit flip transaction. It works with three accounts, the flag account, the user account, and the scammer account. The flag account and the scammer account are controlled by the scammer. So when the scammer is asking the user to sign this transaction, the flag balance equals 0. So the user sees what happens in the first if branch, the transfer of tokens from the scammer to the user. But after the user signs the transaction, the scammer sends another transaction before that to the flag account to increase the balance. And in the end, when transaction goes on chain, it actually transfers all user funds to the scammer. How to defend against it is quite hard, but we needed to act fast. So what we did, OK, there are not many new apps appearing on the blockchain, maybe 5, 6 a day. So we just, for all the apps that are using this specific API that allows bit flips, we're just showing this warning. And how it worked in real life, the developer would use this API, and before releasing, if they test good enough, they can see this warning. So they write to our email, we review the domain, everything's good. And it wasn't a good solution, but it worked. That's good enough. And you can imagine the threshold of apps that went on this third list, like the simulation allow list, wasn't too good. There were some hackathon projects, some side projects. So the developer resources were poorly managed. And some apps didn't have good enough input sanitization. So that's why some scammers figure out how to exploit these apps to use bit flips and originated transactions from them. How it worked? They are crafting some URLs. I like the last one. I didn't know that you can use the onError HTML attribute to run some inline JavaScript that is using some dynamic import. You use a third party that fixes all the course issues, and it loads some malicious JavaScript. So they will go on Twitter, post about free money, post and advertise on Twitter, and users go on this website. Because it's allow listed, the malicious JavaScript loads, it renders an overlay on the original UI, and it prompts you a transaction. And it originates from the allow listed domain, so they use a bit flip. We had a solution for this later, but before, let's talk about this kind of allow list situation, because it's manual review, it doesn't scale, it adds friction, everybody's annoyed. Yeah, and here is the third insight is inside this problem. Sometimes it's fine to not have a best solution, but if you need to act fast, you need to balance between short-term and long-term solutions. In the first few weeks, the allow list fix saved a few $1 million from our users. So it wasn't good, but it was good enough. Yeah, so before any of this happened, before bit flips, we had a project in research and development where we tried to fix this problem thinking from first principles. We had these kind of two principles. First one, we know how the transaction is going to change user assets because we are doing the simulation. And we know that a transaction reverts on chain if there is an error during execution. So we need to somehow encode the simulation to the execution runtime. And we had a project that is called Safeguard. Basically, what it does, it takes the simulation, it generates some assertions, and it appends to every new transaction we don't still trust. So basically what happens, you can see here 5 assertions were appended, and they check different aspects of a transaction. Let's say if, in our example, the user just should receive some tokens, their balance shouldn't be less than their current balance. So the assertion fails, the transaction fails. If the assertions succeed, the transaction succeeds. So it's now in production. So the last insight is to build a system that leverages the underlying technology. You need to understand, we needed to understand that we can encode simulations as part of a transaction. There are more things, more interesting things happened during this whole process, but yeah, I don't have time to talk about all of them. If you're interested, let's grab a coffee and talk about them. Thank you.